So guys, for our Latch circuit, we're going to require some few logic gates. We are going to use 2 NOR gates, 2 AND gates, and 1 NOT gate. Now those are the logic gates we are going to use. So we'll try to arrange them, then we can start. So the first section begins with the AND gates, then it goes to the OR gates, NOR gates, and then the output. So we are going to start with this AND gates, the input section of the AND gates, and we are going to require a signal, or we are going to require an oscillator. I'm going to use a 0.5 Hz signal generator, and it's going to be taken as an input on the first AND gate, and also as an input to the second AND gate, like that. Then the other input of those AND gates, we're going to require a switch. So this switch connected to the other input of that AND gate. Then to the first one, I'm going first to pass it to a NOT gate. Then the output of that NOT gate enters the AND gate. Yes. So immediately you can see because the NOT gate gives a 1 and the signal generator also gives a 1, when they're both 1 on AND gate 27, let me try to label it and call it AND gate 1 just to make work easier, and this I can label it and call it AND gate 2. So once both inputs are on at AND gate 1, it gives a 1 output, and AND gate 2, because only one input is on, the other input from the switch is off, then it's going to give us an off output until both inputs are on. So the output of these AND gates, I connect them to the input sections of these NOR gates, so that I connect it to that point. Then the other I connect it also to that point. Maybe we can call this NOR gate 1, NOR 1, and this can call it NOR 2. And the NOR gates, I just interconnect them just like I interconnected the other circuit of the set reset latch. So the output of first NOR gate connected to the input of the second NOR gate, then the output of the second NOR gate to the input of the first NOR gate, to the input of the first NOR gate, like that. Then this output section, we can put 2 LEDs to show us how our circuit is behaving and to help us understand what's really going on. So in this NOR gate 2, I can connect it to red. Then our first, I can connect maybe green, nope, we want green, like that. So just like that, you have just connected a Latch circuit, and it's pretty much the same as the set reset latch, only that this time we are using the clock to enable us, or to enable the circuit when the clock is on. And let me try to explain it. We are using that switch. So this is pretty much the same as the set reset latch. And for those who are new to logic gates, for the NOR gate, when both inputs are off, it's going to give you a 1 output, and that's why the red LED is on. And because the first NOR gate has a 1 input, it's going to give us an off until both inputs are off. It's when it's going to give you a 1 output. So that's what's happening with the NOR gate. for an AND gate, both inputs have to be on for it to give you a 1 output. That's why when AND gate 1, AND gate 1, when the signal is giving a 1 input, and because NOT gate 28 is giving a 1 input, then the AND gate 1 oscillates between on and off because of that signal. When it gets the signal that both inputs are on, it's going to give you a 1 output. So once I press this switch, it's going to turn on AND gate 2 when the signal will be 1, will be on, when the clock will be high, and once it turns on, it's going to turn off NOR 2 because there will be an input of 1 in its input section that will turn off red LED, and because that output is also taken as an input on NOR gate 1, when the signal is off, it's going to turn on the green LED, and that's what we expect. So when I turn this on, yes, when I turn it on, the circuit now shifts, and the green LED is on, NOR gate 2 is turned off, NOR gate 1 is turned on, and the output is also turning off. It's also disabling the NOR gate 2 because it's also taken as an input in NOR gate 2. So for us to return the circuit back to its initial state, we have to press this switch once more, and I press it. Yes. So once I press it, the circuit turns back to its original state. NOT gate 28 is on, turning on AND gate 1 when the signal is high. That in turn turns off NOR gate 1. Turning off NOR gate 1 also enables NOR gate 2 to be on because both inputs of NOR gate 2 are off. And that's basically what a D-latch circuit works. So it only changes the state when the clock signal is high. So in the other input section, the other input section of the switch, you can turn it on when you're feeding data, and once the clock will be high, then your input will be fed to the circuit, and it is going to give you a 1. Once you turn it off, the circuit now returns back to its original state once the clock signal turns back to be high again. So that's basically what we are going to do, and yes, please enjoy. So guys, this is the demonstration of the set and reset latch simulation that we have just showed you. It's pretty simple. You have only those three. You're going to require those 3 logic gates: the AND gate, the OR gate, and the NOT gate to make the circuit work. My input section is right here. So for the switch, for the data, I'm going to call it data. For the data, I'm using a dip switch. For the clock signal, I'm using an NE555 in oscillator mode. And so those are the input sections. These are the logic gates. We have the AND gate, OR gate, and the NOT gate. And this is the output section. So we have the green LED showing us when we are feeding data, and the red LED showing us when the circuit is at its usual state. So that's basically what this circuit is. I'm going to put a link below on how to connect NE555 oscillator mode for those who don't know it, and I'm going to also put multi-vibrator circuit. If you don't have an NE555, you can use a multi-vibrator. It works pretty the same as an oscillator. So I'm going to turn on the circuit. I'm using a 5-volt power supply. You can use any from 3, but please check the ratings of your integrated circuits. Make sure that you don't damage them. So I'm going to turn on, and the circuit is on, and immediately you can see this clock signal is on, and our output section the red LED is on, showing us the circuit is at normal state when there is no data. So once I press on this switch, we expect the green LED to be on, since it's going to be enabled by the other NOR gate to be on. So that's what we're going to do. So I press this switch, and only when the clock is high is when the other input will turn on. Maybe because the signal is pretty fast, you're not going to notice that, but only when this will be on is when it changes the state of the output. So if I turn this off, only when this will be on and notice that the other input is off, is when the red LED will be on. So if I turn it off, let's turn it off, and the red LED is on. So let me use a much slower signal for you to understand what is really happening. This is a 470 microfarad capacitor, and let's use it instead of that 220 for you to notice the change that I'm talking about. So this is much slower than the other one. You can see it takes bit some time before it turns off. Let me check if I've connected it well. Yes, like that. So it takes some time before it turns off, then turns on back again. So we are going to time when, let's time when this will be off. I'm going to turn this on, and you'll notice nothing will change until this turns back on. So let's time it. When it turns off, I'm going to turn it on. Then, so when this is on and notices that you have changed something, it's only when green will be on. Then we are going to turn it off. We are going to time it again. When it will be off, I'm going to turn this off, and yes. So when this notices that there is a change here, then it's going to shift back to what you have done. So it pretty much notices what you have done, and it changes the state at the output. So we are going to time it when it's off. Then it notices that there's an input that you have fed the circuit, green, and we're going to turn it off. We're going to turn it off, time it, turn it off. Then it turns back to red. So that's basically how our latch circuit works. This much more improved as more than the set reset latch, and yes, so I pretty hope that this is not pretty hard for you guys. It also took me time to understand it and to build it. Next time we are going to move much closer in making a functional memory, and we are also moving on to make the ALU together with the memory and the registers, and I will be much closer to understand how computers work. So thank you very much guys for watching. Please subscribe to Tronics Energy, where we do fun stuff all day, all time.